Hello, good morning. I will be the first presenter for today. So they say save the best for last. Don't worry, this is my last presentation for the day. So I will do my best to present it to you. Okay. So the topic is about enhanced wireless point-to-point using Mikrotik router. So my name is Mar Aeschyllus Flordeliza. So don't worry, they seldom use my second name, so you could address me as Mar. Okay, so I'm from United Plexus. My colleague is Sir Kim, so the one taking picture. Okay, so we are privileged to have all the Microtik certification with United Plexus. Then let's go to the topic for today. So what will be our topic for today? So first we'll see how to set up the easy wireless point-to-point. So the basic, because we will use it later on. Then our wireless point-to-point plus. So the first is we will add the wireless with the VLAN, EOIP, and dual one. Then we will also add the BRRP or the hardware redundancy. Then we will have our PoE router with NetWatch. So we will see what will be the advantage of these three different setups. So first, which way do we start? So we start with this. So our basic wireless point-to-point. So as we all know, a wireless point-to-point can connect us from 0 to 70 kilometers or more, provided we have a line of sight. Okay. So basic configuration of wireless point-to-point. You could use it from office to home or office to office. You could also use it for your multi-site. So basically, when you purchase a router, as you can see, there's no line, there's no configuration, there's no link yet. So what we have to do is to configure AP and client so that we have connected two different areas in the same single LAN segment. So configuration on AP side will be like this. So you will just need to configure your mode to AP bridge, then have your SSID and the password. So as simple as that, you have enabled your wireless. Okay. After that, you should bridge your Ethernet 1 and your WLAN 1, which is the interfaces present on your point-to-point. So that basically gives you the connection like this. So your APS broadcasting and your LAN is connected. So for the next site, for the client site, we have to configure same thing, configure your mode to station bridge. This one, mode to station bridge, because we need to bridge it on your in your Ether 1. So again, set up your password, then scan and then connect. So after that, bridge your Ethernet 1 and your WLAN 1. Okay. So this is basically what we get for configuring the basic setup for our wireless point-to-point. So basically after that, you have connected your two sites. So when there's a present router here and you have a switch here, you could distribute whatever is in this first office in a single LAN segment, like printers, servers, and so on. Okay, so that's the basic setup. What will be benefit from this one? So have two or more sites running on a single network segment, and also a easy resource sharing between the two sites. Okay. So for improvements in security, we always could repair to the high throughput settings of Mikrotik, the TX power expansion, then the wireless chain. We have now triple chain aside from the dual chain and single chain, and then also the alignment of your wireless. Then after that, we have to improve our security. We could have it through MAC filtering and of course your encryption key or your passkey. Okay, so that's the basic setup. So what if we could add from it VLAN and dual one? So what do we need first? So we need to have a Mikrotik router present on both locations with at least 3 Ethernet ports each. Then an ISP is present on both locations. Okay. So configuration benefits first, so that we could have it. What will be benefit from this configuration or this setup? First is to maximize usage of both ISP on both sides. Then avoid possible downtime of internet. So from this, we have multi-one and a multi-site internet resource. For example, you are living in Pasig, and the other site is on Makati. Whenever the Pasig area have the internet down, you could always get the one from Makati because you are having a multi-one or a dual one. Oh, so optimize the use of the point-to-point link. Okay. So we will share the one and still manage to be on a single LAN segment. So we will have to, aside from passing the local network of the other site, we will also pass whatever ISP is present on both locations. So this is the setup. So a while ago, we created the point-to-point, and then we have an ISP present on both sides. So the setup suggested would be like this. So for example, we will represent AP with the red color ISP, and the client side with the blue colored ISP. So through the Ethernet 2 of our router, we will transport the ISP on the AP side to the client side. Through the same point-to-point link, we will pass the ISP of the client side to the first site. Then the LAN segment will be, you could still benefit to be on one single LAN segment represented by your yellow line. So typically 3 networks are running on your single point-to-point. So this is what we created. So how do we create it? First is we will start with the configuration of our router board on the AP side. For this example, I use an RB951. So first is to configure VLANs. Basically, we need to configure 3 VLANs. One VLAN for your VLAN 100 to be able to share your one native ISP to the other site. You will also use another VLAN 200 to fetch the ISP on the client side, and we will use VLAN 210 for your EOIP tunnel. So all of the VLANs will be under your Ethernet 2 or the port where you will link your point-to-point. Okay, so after the VLAN, you have your EOIP tunnel. So on my EOIP tunnel, I just use a point-to-point IP. As you can see, it's 10.10.10 and 11.11.11. So we will configure it later on the IP side, and I use the tunnel ID number 5. So as we all know, EOIP is a proprietary of Mikrotik to be able to link 2 sites over IP to be linked in one single LAN segment. This one is always used on ISP to ISP, but this one we will use only point-to-point IP. So next thing to do is to have your bridge. So bridge, we will put 2. One bridge for your VLAN 100, which is your bridge for your native ISP, so that you could transport it to the other side. And one link is for your local. Then we will put bridge ports onto it. So as you can see, I have 5 ports for my local, which is my EOIP tunnel. So basically, they will be through the EOIP tunnel, we will have a layer 2 connection. Then Ether 3, 4, and 5 also under your local. And for your wireless, you have your WLAN 1 to be your local. So this is configured on your RB951 present on your AP side. Then you will put your ISP on your Ether 1, and we will bridge it with your VLAN 100, which is a while ago is under port number 2. So we will configure IP for static. So I represent my IP for my native ISP as 100.100.100.96 network, and for the ISP number 2 is 200.200.200.96 network. So as you can see, I put the IP of my native ISP on the VLAN, on the bridge ports, because you could never put an IP on the ports that is under a bridge. So always take note of that if you put a port under a bridge, you should always always put the IP on the bridge that you created. So to fetch the second ISP, I put it on the VLAN 200, which is I created under the port number 2. And then I put my IP on my local as 192.168.100.1. So that would be the gateway for my local. And as we configure on the point-to-point IP of our EOIP, we put address 10.10.10 and the network as 11.11.11. So on the remote site, we will reverse these two. We can see it when we configure the RB on our client side. So if DHCP is applied, we could always configure still our local to be the static and our point-to-point as our as also static. Then we could always do the DHCP client on our VLAN 100 and VLAN 200.1.2 provided a DHCP is supplied. But take note, because we are using dual 1, always take note that when you get an IP or a DHCP and using a dual 1, always check the add default route to no so that your ECMP or your PCC will work. Okay, so we will have a manual routing. So configure the DNS, so very basic to have internet, and check allow remote requests. Then the DHCP pool. So this is the trick for the DHCP pool. You'll create it in local, but you will assign a range. So for AP site, I will assign a range from 102 to 150 only. So the next range will be used by the client side. So the 50 PC here will be seen on the other side as if they are on single LAN segment. Okay. Then for firewall NOT, so we put the IP a while ago on bridge VLAN 100. We should also masquerade VLAN 100. Then for our VLAN 200, we could masquerade as dual 1. Okay, so for this setup, I use the easy Mangle rules for ECMP, which is I just put 2 mark connections for input. So bridge VLAN 100 input and VLAN 200 input. So 1, 1 and 1, 2. Then for the output, 1 con and 1 con is 2 1 1 and 2 1 2. So the routing mark, we will see it or we will use it on the routing later on. So if we want the ISPs to be on ECMP or load balance with failover, we will use the ECMP routing. We will put the gateway of the native ISP and the gateway of the other ISP. Okay, so that will have you load balance and failover. But if we want just failover, just use the routing distance. So as you can see, I use my native ISP as my default gateway, and whenever that goes down, I will automatically be transferred to the ISP of the other side. Okay, so that's the configuration for our AP side. So let's configure the client side. So client side has a similar configuration with the AP. So again, you should have your VLANs. So on this time, your VLAN 100 will be your 1.1. VLAN 200 will be your 1.1, and VLAN 100 will be your 1.2. Okay, then they are also connected under Ethernet 2 because we will put the point-to-point on Ethernet 2. Then EOIP has the same VLAN ID, and we will just inverse the IP. Okay, for EOIP tunnel, as we can see, a while ago we used the local address 10.10.10 here and 11.11 as our remote address. For now, we will use the local address as 11.11.11, then the remote address as 10.10.10. And the tunnel ID should be the same. So bridge your local, and now bridge VLAN 200. Okay, so we will put under the ports, under local, so we will bridge again the UIP tunnel that we have created and all the LAN ports, including the wireless, then the Ethernet 1 and the VLAN 200. So this will typically have your local network and your VLAN 200 transported on the AP side. So IP for static again. We use now 100.100.100 for 1.2, and 200.200.200 for our native ISP. Then, as you can see, we used a while ago 192.168.100.1 to be the local gateway of the AP site. Now we will use 192.168.100.100 to be the local gateway of this network. And then inverts the point-to-point address 11.11.11 and 10.10.10. So you could always use the DHCP supplied. Again, we will use 100.100 as this IP and 11.11 as its native address for EOIP. Then after that, we will have our DHCP supplied IPs and no default route. Okay, so add your DNS and check allow remote requests. So the difference on the other side is this one. So you will use the pool. The next pool, the DHCP pool is 192.168.100.101 to 100.150. So basically, I skipped the 51 to 99, so no one will be able to use it, but it's still usable in the network. But this time, as you can see, we are still on single LAN segment with the other side, so we could ping them through the help of the EOIP. So we will use firewall NAT again. So bridge VLAN 200 because we bridged the Ethernet 1. That's why we will have a masquerade over there. Then the VLAN 100.1.2. Then for the firewall mangle, again, we will have the MAR connection input. The VLAN 200 is now on 1.1 and the VLAN 100 is now on 1.2. So 1.1 connection to 1.1, 1.2 connection to 1.2. Again, the routes will be the same. You could also always use ECMP load balance plus failover or just a simple failover. Okay. So, this is the setup that we have achieved. Again, we passed the ISP of the AP to the client side. We passed the ISP of the client to the AP side. And be able to use EOIP to be maintained on one single LAN network. So what do we benefit from it? Maximize usage of ISP on both sides. Avoid possible internet downtime because of our multi-WAN and multi-site internet source. So you will just not rely on having two ISP present on the same site with different company provider, but you could also have same company provider coming from somewhere else. Then optimize use of point-to-point link because we just not use our point-to-point link to be a single point-to-point. We use it to pass multiple network. So we share the one and still maintain the to be a single LAN segment. So you still access the server, printers, and everything. Okay, so that's for our ISP failover. So we will now have our wireless point-to-point setup with hardware redundancy. So this needs sites to have two wireless router boards each. Then configuration of two routers will be identical. And we will apply Brrp for hardware high availability. So a while ago, first, we discussed the configuration benefits. So we will have available backup without having wireless interference because your backup wireless is turned off. Then we will avoid wireless downtime. At the same time, we have automated wireless backup. So what basically happens on a point-to-point link? So this is the initial point-to-point. Once a router is busted, your link is disconnected. What if we could have failover to it? So this is a typical Brrp setup. So you have two masters and you have two backup router for each site. So these two routers on AP site has same configuration. Basically identical configuration except on the Brrp configuration. This also on the client side have the same identical configuration except for the Brrp. So initially The masters are the one connected, and once they are down, the backup will automatically act what they are doing. So this is basically the configuration on our AP side. So aside from this configuration of AP bridge and our Ethernet 1.1 and 1.2 being bridge, we will have additional configuration for these two. So the AP side is connected. This two is the AP side, so they have the same configuration. So we will have additional configuration on AP sides. So the one will act as master and the one will act as backup. First, we configure the additional for BRRP on the master. So BRRP configuration on the master will be, you will add a BRRP port. You will put it under the local, and BRID is number 10. We have a priority 200. Priority will declare who will be the master and who will be the backup. So the closer to 255 you are, the greater the chance that you will be the master. For this, I will use 200 and 100. So for the master, I will use priority 200, and for the backup, I will use priority 100. So what this thing will do? This thing will do on master interface enable wireless LAN 1. So basically, when it becomes or act as a master, it will enable its wireless. Then, when it becomes a backup, it will disable its wireless. So what will be the configuration needed for the BRRP to be on? Of course, when you configure the BRRP, you just add interface, but it will not act as accurate as it was, except when you have a BRRP IP and a monitoring IP. So we put the BRRP under local. So we should put an IP under local. So I will use 192.168.100.5 for the master. Then this BRRP address should be the same with the backup side. So I use 50.50.50 here on the master. I will also use 50.50.50 on the client side or on the backup side. So let's configure the additional for the backup. So same thing. You will have BRID number 10, but this one has lower priority for it to become a backup. So I use priority 100, and this one interface local. So the same thing he will do. The same thing it will do. When on master, it will enable its wireless. When on backup, it will disable its wireless. Okay, so again, configure your IP. So BRRP IP is the same with the master, because this will determine whether the master has die off or is on. Then I put a monitoring IP 100.10 for the backup. So basically, same configuration on the client side. You will just need to have different BRRP IP and a different monitoring IP address. So what will this setup do? The typical setup, your master is connected to the master at the client side. So once the master on the client side goes down, your client's backup will automatically turn on its wireless and connect to the master on the AP side. So you will still have the connection. Same thing will happen when the master AP goes down. The backup acts to be the new AP, and the client master connects to the backup AP. Then, if both masters are down, you can still manage to have the link because they have same configuration, same SSID, and same everything except for the monitoring of the BRRP IP. Okay. So what will be the configuration benefits again? We will have available backup without having wireless interference because the wireless is turned off. We will avoid wireless downtime and automated wireless backup. So we have done two setups. One is the backup internet and another one is the backup hardware. So we will tweak more on this backup hardware. So we will have now a wireless point-to-point setup plus NetWatch. So this can be used if you have Mikrotik router with multiple PoE ports. Mikrotik has recently released the RB 750p, in which 4 of its ports is having a PoE out that could power our S60s. So what will we do? So what will we have as benefits on this configuration? So aside from having wireless backup without wireless interference, we could avoid wireless downtime, and we have automated wireless backup. We also have, and we could also save the backup router from wear and tear of the circuits. On BRRP, both of your routers, backup or master, is on state, or they are both running. They both receive electricity. The components can have wear and tear just for the static electricity running onto it. But on this one, we also have power saving for having the backup as state as off. So you basically have a backup that is sleeping or not working and will only turn on once your master goes down. Okay, so basic BRRP setup is this. So we will improve on that. So we will have a PoE plus netwatch where we will use power box on both sides. So power box master, on the power box, masters are connected onto its Ethernet 5. The same thing as this, the master is on Ether 5, and we will put the backup on Ethernet 4. Okay, so backup is both on off state, meaning the PoE on the Ether 4 is turned off. So basically, configuration on AP side again, you have your AP plus bridge, then your password, then bridge your Ethernet 1 and WLAN 1. We need additional configuration for the S60s just to have the master put an router IP. Just put the router IP on the main S60 AP. So I use again 100.5, and again to the client side or the backup site, I mean, is 100.10. So we have two monitoring IPs for our master and backup. So we could now monitor if the master is still running or not, that we will use on the netwatch. So for our PoE router, which is I use RB 750p, I bridge all the ports. So Ethernet 1, 2, 3, 4, and 5. So I just labeled the Ether 5 as main and Ether 4 as backup. So also put a router IP on its local for you to be able to monitor the IP of the two S60s, both master and the backup. So what will we do in the netwatch is this. We will netwatch the IP of the main. So I will netwatch the host 192.168.100.5, the intervals every 15 seconds. Then what will I do? On up, I will turn off always the Ethernet, the PoE on the Ethernet 4 using the script interface Ethernet PoE set Ether 4 backup PoE out as off. Then when the 100.5 is down, I will automatically turn on or force to on the PoE of the Ether 4 so that it will turn on the secondary or the backup router. That's using script. So the same thing as configuration on the client. Put a monitoring IP on the master and the backup and configure your PoE or RB750 on the client side. Okay, so this is typically the failover. So aside from BRRP a while ago, this one, once the master of the client is down, it will automatically turn the state on for its backup. Also in vice versa, the master on the AP side is down, the backup router will be state on. And if both of them are down, we could have both the backup as on. So we save them from wear and tear and possible depletion of the circuits whenever it's just stays as backup. Okay. So again, what is the configuration benefits? So having available backup without having wireless interference, avoid wireless downtime, automated wireless backup, save the backup router from wear and tear up to circuit components, then power saving for having the backup state as off. So conclusions. Mikrotik Wireless can be combined with different features. Mikrotik's multiple features compact in a single router board is a great advantage. As long as it doesn't violate any networking rule, your creativity can create new solutions using combined Mikrotik features. Okay, so the last steps will be to thank you all for listening and for having this great talk. Then this is the end of my topic. We could have question and answer if we still have time. Once again, my name is Mar Aeschyllus Flordeliza, and coming from United Plexus, and you could email me at mar.flordeliza@unitedplexus.com. Okay?